Now that we've seen our basic building blocks, let's look at the second pattern, wrappers. This pattern solves one of the biggest challenges in software development, adding cross cutting concerns like logging, error handling, and performance monitoring without polluting business logic. Now, consider the traditional approach to adding logging. You typically do something like this. Look at what's wrong here. The business logic, which is filtering records based on a predicate, is now tangled up with infrastructure concerns like logging. The system.out.println statements are scattered throughout the method. If you want to turn logging on or off, you'd have to modify every single processing step. If you wanted to add timing or error handling, you'd have to modify every step again. The wrapper pattern separates these concerns completely. Now, let me walk you through this carefully. The logging wrapper also implements processing step. It has the same uniform interface as everything else. But instead of doing any business logic itself, it wraps around another processing step that we store in the inner field. In the process method, we first log that we are starting and we record the start time. And then, this is the key part, we delegate to the inner step by calling its process method. We're not changing or interfering with the business logic at all. After the inner step completes, we calculate the duration and log the completion. Notice the try catch block. If the inner step throws an exception, we log the failure and then rethrow the exception. This way, we add logging without changing the error handling behavior. Now, you can add logging to any step without modifying the step itself. The original email filter is completely unchanged. It doesn't know or care that it has to be wrapped with logging. We can use it in a quiet pipeline without any logging, or in a verbose pipeline where both the filter and the transform steps are wrapped with logging. The choice of whether to add logging is made at composition time, not when we write the business logic. Now, the power of wrappers becomes evident when you need multiple cross cutting concerns. Here's an error handling wrapper. It takes an error handler function that defines what to do when an exception occurs. In the process method, we try to execute the inner step, and if it throws an exception, we apply the error handler instead of letting the exception propagate. Here's a timing wrapper that measures how long a step takes to execute the records and duration using a time recorder function. Now, watch what happens when we stack multiple wrappers. Let me trace through what happens when we call the robust steps process method. The timing wrapper starts a timer, then calls the error handling wrapper. The error handling wrapper tries to call the logging wrapper. The logging wrapper logs that it's starting, then calls the actual email filter. If the filter succeeded, the result bubbles back up through the layers. The logging layer, the logging wrapper logs completion, the error handling wrapper just passes the results through, and the timing wrapper records the duration. If the filter throws an exception, the logging wrapper logs the error and rethrows. The error handling wrapper catches it and returns an empty dataset. And the timing wrapper still records the duration. The beautiful thing is that each wrapper adds exactly one concern, and you can compose them in any order and in any combination. The wrapped component, our original email filter, remains unaware of and unaffected by all the wrappers around it. This pattern transforms cross cutting concerns from scattered conditionals and repeated code into reusable, composable components that can be applied wherever needed.